Okay, so everyone should be looking at this. Go ahead and start here at problem number 1. Remember, there was a part of the test that I projected up on the screen on Friday, where I'm going to give you guys just some labeled angles, no calculations required or setting up equations, but you will have a section where you are looking at the labeled angles, and you need to identify what is the angle relationship. Okay, so hopefully you went through on Tuesday or on Friday, and you went through and answered all those questions so that you're prepared for that. But those are supposed to be the easy points. Just look, identify, and move on. These we get a little bit more in depth. We have to identify the angle relationship, write down an equation, and solve. Okay, so in this first one, these are all, ideally you can get all these done in just one step. I will show you what happens in some of these if you don't see it as one single relationship. But anyways, if you look at this one, this is one angle relationship. And what would you call this? These three angles. Angles on a line. All right. So here under the first column, the first blank you need to fill in, you could just write angles on a line. If you can't fill this in on that line, just make sure it's in that box. If you forget the abbreviation for anything, just write out the full phrase. It only takes a few seconds longer anyway to do that. Remember, I mentioned this on Friday, but on the test, you will have the 14 rules. I'll just write the names down. It might be up on the board. It might be actually printed off on the test. But you will have the name of all 14 rules, but I'm not going to give you any other information about it. What it looks like, or if they add up to 180, or if they're congruent. You need to know that stuff. So if you don't know that right now, you need to spend your time studying your flashcards and memorizing that. Okay, so the equation here, angles in a line, are these congruent or do they add up to 180? They add up to 180. So I have an equation. It does matter how we set up the equation, but there are some different ways you could do it. So I've got three angles, 15 plus A plus my third angle, 38, all add up to 180 degrees. That's the equation I need to have written down. So what I don't care about is this 15, A, and 38. If you mix up the order of those, that doesn't matter at all. But I need to see that all three of those angles add up to 180. And now we need to show the work. There's not a whole lot of complicated work to this one. I'll just rewrite the equation real quick. 15 plus A plus 38 equals 180. And if I add the 15 and 38, what do I get? 53 plus A equals 180. Subtract 53 and we get 127 degrees. As far as the work goes, you don't have to write out every single thing that you do. And I know a lot of you could probably just do this in your head. But I don't want to just see your equation and your answer. I want you to show me something that you did. Maybe you just write down this 53 plus A equals 180. And that tells me that, okay, they combined their like terms, and now they just subtracted the 53. I can kind of figure out the rest of it on my own, but if I just see an equation and an answer, then I want to see some work associated with it. Okay, next one. The angle relationship here, we've got x and the 72 right here. What would you call that? Linear pairs. Supplementary or congruent? These are supplementary. They add up to 180. Okay, so now we've got x plus 72 equals 180. And this is why I keep talking about whether angles add up to 180 or if they're congruent, which is most of our angle relationships. Because this is going to determine how we set up our equation. Okay, so this one right here, x plus 72 equals 180. Subtract your 72 from both sides, and we get what? 108. There it is. Not a whole lot to that problem. One of the maybe the simplest one we have on the page. I don't know. Okay, were there questions on the first two? Okay. Yeah, now we get to ones where the algebra gets a little bit more complicated. And the first thing we want to do is identify our angle relationship. So what would you call this? If you have your 153 right here, your x minus 4 and 2x plus 10, what would you call that? EAT. EAT. Exterior angles of a triangle. Okay. Now, exterior angle of a triangle, we know, what's the rule basically tell us?
That it equals the outside.
There you go. The two, and it's hard to maybe remember the terminology for all this, but these interior angles add up to that exterior angle 153. Okay. So I've got x minus 4. This is kind of a longer equation. Oops. X minus 4 plus 2x plus 10 equals that exterior angle, which is 153. All right, so I'll go ahead and rewrite that in this box where I'm supposed to show my work. I'm rewriting it exactly as is. X minus 4 plus 2x plus 10 equals 153. All right. Shouldn't be too hard of an equation, but we do have number terms and variable terms. When I add the variables together, I should get 3x. Add the numbers together, that's minus 4 plus 10, which is going to make that, plus 6 equals 153. I would definitely expect to see a little bit more work on a problem like this. So 3x plus 6, I'm going to subtract 6 from both sides. What does 3x equal? 147 when we subtract that. Divide by 3, what does x equal? 49. Okay. And if you want to go back, you can confirm that. You can actually plug the x back into those angles. You can do x minus 4. You can do 2 times x plus 10 and make sure that adds up to 153. Yeah. Okay, yeah, and that's the other thing. I'm glad you mentioned that. With this angle relationship right here, you might not see the exterior angles of a triangle. And that's not the end of the world for me. As long as you show me, and what Logan just mentioned is that he used linear pairs. I'll show that in a different color real quick. I'm not going to do all the math. But he first did linear pairs and found this angle, which I'll call Z. And then once he did that, and he knew the actual number, it was 27, is that right? So that's 27 degrees inside. So once you know that, you can do triangle sum theorem. As long as you write it out and make sure it's clear, and you write down in this box, what is the angle relationship? Linear pairs and triangle sum theorem, then I'm okay with that. I'll definitely give you full credit. I will tell you all of these can be done in one step, but if you just don't see it, show me something that you do see. Okay? Okay. Number 4. What is this angle relationship? That's alternate interior. The equation, are these supplementary or congruent? They are congruent. So I'll go ahead and show that. 8x minus 4 equals 60. All right. So hopefully you guys are seeing that. As far as where the equation is coming from, 8x minus 4 equals 60 degrees. So now we can just do the work real quick. Again, for the work, I just need to see something that shows your thought process. If it's just the equation and the answer, then it looks an awful lot like you might have looked on someone else's page. So I don't want that to be a thought that runs through my mind. All right, add 4 to both sides. 8x equals 64. Divide by 8. X equals 8. Okay. Any questions on those two? All right, next two, we can kind of make it a little more straightforward now. Angle relationship. 5x and 3x plus 34. What is that angle relationship? Vertical angles. All right, vertical angles. We know that these are congruent. So 5x equals 3x plus 34. And now I can do my work. Subtract. I want to get all my x's to the same side, so I'll actually leave that 34 alone, subtract the 3x from both sides, and I get 2x equals 34, divide by 2, and x equals 17. Okay. So I encourage you, if you have this, make sure you're copying down everything that's supposed to be here so that you know what a perfect, or what a good answer looks like. I don't want to say perfect, but you know what a good answer looks like, one that'll get you full credit. This problem right here, this is one that in the past has caused problems. So let's just start with the angle relationship. What would we call this? Same side interior. So a lot of people are able to get that. Actually, that's not really the problem, typically. The problem is that people forget if this is congruent or supplementary. We all know it's what? Supplementary. Very good. So our equation should be 2x plus 4x equals 180. Here's what happens is sometimes, this actually used to be our test that I'm giving you guys for the review. So when I would grade this, the problem was people would set up, they wouldn't know if it was congruent or supplementary, and they set up this really weird equation, 2x equals 4x. Now this does have a solution, 2x equals 4x. What is it? Can anyone tell me? There's only one answer that makes this true. X equals 0. That's the only one that works. So it does have an answer, but it's not an answer that makes any sense. So this is kind of a weird-looking equation, and the reason I'm pointing it out to you is that if you write this down and you're like, I don't even know what to do with this, 2x equals 4x, well, just use that as a sign to yourself that maybe I set the equation up wrong. All right, so the equation should be something that's pretty simple to solve. And now if we look at just this one, 2x plus 4x equals 180. Well, those can combine. We get 6x equals 180. That can divide, and x equals 30. Okay. So just look for a simple equation, relatively simple. And if you get something weird that you don't even know how to do the algebra for, then you probably set it up wrong. Okay. Another one right here that has caused problems in the past, and this is a really good one for us to look at. This, by all appearances, is an equilateral triangle. But if you look at the angles that are given, it's 68, 50, and x. When this was the test, a lot of people just looked at the appearance of it and wrote down that x equals 60 because of equilateral triangle. All right, but the point of me saying this is don't get caught up on the appearance of any of the diagrams. Make sure you're actually looking at the angle measures and figuring it out that way. So even though this appears to be equilateral, it's not. So what angle relationship do we need to use for this diagram? TST, triangle sum theorem. So now we actually need to write an equation which would be 68 plus 50 plus x equals 180. Pretty straightforward from here. 68 plus 50 plus x equals 180. Again, I'm not expecting you to rewrite the equation. I'm just doing this to go kind of above and beyond. But I would expect to see maybe the next line. What happens when you combine 68 and 50? 118. So maybe you just show me this. 118 plus x equals 180. And that shows me you're doing the work. I know the last step is to subtract from both sides. So x equals what? 62 degrees. Okay, the last one. Pretty straightforward as far as it goes. What's the angle relationship with these four angles? Angles at a point, which means, let me reiterate this. Remember, if you forget the abbreviation, don't come up with your own that I'm not going to be able to understand. Because a lot of people, especially angles at a point, they'll abbreviate this AAP, and you'll lose credit because that's not the abbreviation we use. So if you don't remember the abbreviation, write out the full thing. I've already said it, but I just want to reiterate. All right, the equation for this. These all add up to what? 360. So I got 2x. I'm going to have to squeeze this one in. 2x plus 2x plus 3x all add up to 360 degrees. So maybe what I'll do here is I'll just combine all these together. 2x, x, 2x, and 3x combined to be what? 8x. That's all I'll show right here. This works for me. This is good enough to show your work. Okay? Now we divide by 8. Maybe you even want to show that dividing by 8. And x equals what?
45.
45. There it is. So that's the front side. Any questions on those 8? So these are intended to be your easier problems because they are relatively straightforward. Though, I will say this. Out of the 8 problems, I'm hoping that everyone in here gets like 6 or 7 of those where they're like, okay, I know these 6 or 7 are right. And maybe there's 1 or 2 that you guys are like, okay, I'm not 100% sure on this, but I'm just going to give it my best shot. Remember, there is partial credit, and that means don't leave anything blank. Okay, this side, we did have to add some parallel lines. If you weren't here, then you might want to add those parallel lines in. We can solve for A, B, and C in different orders. We don't have to start with A, but let's just do that. It's kind of a logical way of going. Okay, so what I've got is angle A right here. I mentioned that if you have parallel lines in a diagram, you will use one of those parallel angle relationships. So I've got parallel lines right here, and A is going to be connected to this 110 because of what angle relationship? No? Well, there are different ways of doing it. So I heard corresponding and linear pair. Well, we're not to that yet. So corresponding and linear pair does work. Let me show you that real quick. So if I did a linear pair with A and this angle right here, and then a corresponding angle with these two angles, the unknown one right here and 110, that works. We do have a direct relationship between. Yeah. This could also be called same side exterior. And at the very top it says there are multiple ways of doing this. So if you showed me 2 angle relationships, you said, I did linear pairs and then corresponding angles, I'm totally fine with that. You'll get the same answer. But I'm going to go ahead and write that these are same side exterior. So wherever you want to show your work on this, I expect to see some work somewhere on the page. So I know that A plus 110 equal 180 because same side exterior are supplementary. So therefore A equals what? 70 degrees. Okay, solving for B, we can do that one next. Honestly, we could solve for B or C right now, if you can see that, but it doesn't matter. Let's just solve for B. What angle relationship would you use to solve for B? Linear pairs. And this one, there's really just one logical way of getting it done, though there technically is a second way of doing it. But I imagine most people would see that as linear pairs. We know linear pairs are supplementary, so that means that 128 plus B equals 180. And B, therefore, equals what? 52 degrees. Okay, the very last one, we know A is 70. I'll go ahead and write that in. We know B is 52, so how can we solve for C? TST. So on this one right here, all I need to write is TST. I'll go ahead and write the equation inside this box. So I've got 70 plus 52 plus my unknown angle C equals 180. All right, you might go through and show some more work. Maybe that's what you show me right there. And anyways, you get C equals what? 58 degrees. There it is. Any questions on that one? So because you can solve this different ways, and I gave you guys Friday to work on this, you might not have come up with this answer. I want to reinforce the idea that there's not just one way of getting the right answer here, and I am willing to look at what you do in order to see if you get credit for your work. But if you want to come and talk to me later, show me what you did and see if it works, I'll let you know. All right, next problem. These are all parallel lines again. So I made sure that was really clear. You probably would have assumed that anyway. And I've got 42 degrees, 78 degrees, G down at the bottom. We know that we're going to be working from top to bottom. So what angle relationship can we use to get started with? Corresponding. Now we might think same side, but it's not going to be same side. What we've got is 42 is on the top right of an intersection. So is this angle that I just marked in red. So those are corresponding angles, and I'm going to go ahead and mark that down under my angle relationships. All right. So if that's 42 up at the top, what's the other red angle going to be?
36, 42.
Well, this one right here that I just marked is going to be 42 also. All right.
Oh, I thought you meant the bottom.
Oh, okay. Well, yeah, you're right. We're going to get to that one now. So we need to, first of all, solve for this unknown angle. And what would we use to solve for that? So let's kind of think about the situation. We've got two smaller angles that combine to form that larger angle 78. There it is, angle addition postulate. We have done like 3 or 4 problems like this, so I hope you guys can remember this. Angle addition postulate tells me that 42 plus my unknown angle, I can call it whatever I want, I'll just call it x, equals 78. Now we can solve for x. In this case, it's going to be what? And Brandon, you said it a minute ago.
Oh, 36.
It's 36.
So 72 minus 42 is 36.
There you go. So there's our 36 degrees right here. So the last step, I'm going to solve for g. What angle relationship can I use? It's not TST. We don't have a triangle here. We do have corresponding angles. So 36 and g, they correspond to each other, which means this is 36 also. That's my answer. And what I'll do, just to be definitive, one thing I would do is probably give you credit just for this right here. But the best answer is to show me that you're using corresponding angles a second time. Okay, last one. I don't know if it's more challenging or equally challenging or whatever the case, but it is going to be hard to do if you don't know that these lines are parallel. So make sure you've got those marked. Okay, so we're going to solve for x first. Remember, we're starting at the bottom where we know information. We're working our way up toward the variables. So what can we do to solve for x? Alternate interior angles. I got 36 right here and x. Parallel lines means I'm going to use some kind of parallel angle relationship. In this case, it's alternate interior angles. I'm going to mark that right here. No real calculations required. What is x going to equal?
36.
36. And honestly, that's good enough for me. Because we don't calculate, we just say that they're the same. Okay, now we need to solve for z. And how are we going to get the measure of angle z? This is going to be triangle sum theorem. Really, it's just one rule required. Okay, guys. Notice that we've got these three angles that all add up to 180. And it might seem like, just at first glance, like we're going to have a really weird equation we can't solve, but we already solved for x. So if you hadn't noticed it before, we've got a way of getting this done. So I'm going to add those three angles together. X plus 2x minus 15 plus z equals 180. That would be an impossible equation to solve if we didn't already know x. But we do, so I'm just going to substitute that in. 36 plus 2 times 36 minus 15 plus z equals 180. Are you guys with me on this? Okay. Now it's a pretty simple equation as far as it goes. Add all this together. Well, let's just do this real quick. What is 2 times 36? 72. So I'll write this one more time. 36 plus 72 minus 15 plus z equals 180. Close. All right. Yeah, well, and I'll just show this real quick. 36 plus 72 minus 15, just those numbers added together. What do we get?
93.
There you go. 93 plus z equals 180. And now we've got an answer for z. 87. Okay. So that is the test. Now you can't assume that just because I went through the test right now with you guys, that you automatically understand everything. Some of you do, and that's good. Some of you do not, and you'll need to make sure you're still studying those flashcards. Looking back, I gave you guys a lot of practice problems that you might not have looked through all of them yet, and maybe you did, but you can just look at them again. So in the last 15 minutes of class, I'm available if any of this did not make sense. And then if you want to look through any of the past problems, we can look through that as well. So just make sure you're taking advantage to get prepared for the test.